Morning, ladies and gentlemen. Quick video today. We're only going to go over one part from the first problem and one part from the second problem, as they were the questions most asked in the question stream. By the way, just want to comment again, great job by all of you, both asking and answering questions. I really appreciate that, and just keep going. All right, so we're going to talk about part B from the first problem. Part B asks or states that the rate of fuel consumption is increasing fastest at time t equals 45 minutes. What is the value of r double prime of 45? Explain your reasoning. All right, this is a difficult problem, but we have seen this before. It just hasn't necessarily been worded in this way. So let's just kind of break down what this statement is saying. This very first statement, the rate of fuel consumption is increasing fastest at this time. Well, first of all, let's break it into components. Of course, the term rate of fuel consumption, that is our function r of t. All right, so r of t is the rate of fuel consumption. Okay, so then that means the term rate of fuel consumption is increasing simply means that if we were to look at the graph of r of t, we'd see something like this or like this, right? Both of those, or even maybe a combination of both of those. The bottom line is all we know from the first part of that statement is that r of t is going up. Okay, let's keep going. It then says, it adds the word fastest. So rate of fuel consumption is increasing fastest. So now this kind of introduces a speed element or a rate of change element into our rate of change function. So another way of interpreting the statement, rate of fuel consumption is increasing fastest, is to say that the rate of change of the rate of fuel consumption. So again, remember, this is just r of t. Okay. So we're saying that the rate of change of r of t is at a maximum. Okay. Well, how can we denote the rate of change of r of t? Well, that of course is r prime of t. So realistically, this statement, I know there are arrows all over the place. Let me use a highlighter. Realistically, this statement is equivalent to saying that r prime of t is at a maximum when t equals 45. And therefore, what we know, hopefully, from prior videos and from prior lessons during the middle of the year, is that if a derivative has a maximum at a certain point, then at that point, the second derivative must be equal to 0, right? You can think about it. So if we were to graph the derivative function, if the derivative function has a maximum at a certain point, let's say this is when t equals 45, well, if r prime of t has a maximum when t equals 45, well, that means, that's supposed to be a tangent line. Well, that means the tangent line slope would be 0, or in other words, r double prime of 45 would equal 0. All right, so I'll go ahead and complete this statement. So r double prime of t equals 0 at t equals 45. All right, so an argument would just simply be that since the rate of fuel consumption is increasing fastest at t equals 45, that means r prime of t has a maximum at t equals 45, which finally implies that r double prime of t is equal to 0 at t equals 45. Okay, so there you have it. A tough problem because of the way it was worded, but it's a concept you have seen before. It's a concept you know. So I promise you, ladies and gentlemen, when the AP occurs, you know everything you need to know. It's just a matter of, will they word it in such a way that maybe you haven't seen before? And that might be the case. So you just have to think carefully through each and every word sometimes in order to sort of figure out what they're saying in terms of what you know. Okay? Anyway, tough problem, but hopefully now this makes sense. All right, moving on to the second problem, part D. Also a tough problem. Again, dealing with the second derivative. Second derivative seems to be a sticking point for many of us, and that's fine. We'll keep practicing. So the question asks, are the data in the table consistent with the assertion that t double prime of x is positive for every x on this interval? All right, a couple of things. I want to make note that we were told that t is twice differentiable. This means that t is differentiable and also t prime is differentiable, and that's going to be important in just a moment. Now, what does t double prime being positive tell us? So if t double prime of x is positive, that implies that t prime of x is increasing. So the thing is, if we're trying to assert that t double prime is positive for all x on this interval, we then need to somehow show that t prime of x is increasing on the entire interval. Or if we show that t prime of x is decreasing at some point, then we have kind of proven that t double prime of x is not greater than 0 over this entire interval. So what we're going to try to do is see if we can prove this for every single point or find a counter example. All right. Now, we are only given information about t. So how am I supposed to prove something about t prime if I only have sort of snapshots of t? Well, we've seen from previous problems that we could actually approximate the derivative by using slopes of secant lines. And so that's what we're going to do here. So to approximate t prime of 0.5, I used these points here, and I found the slope of the secant line that connects those 2 points. That slope is -7, and that gives me an approximate value for t prime of 0.5. Okay. I then went ahead and chose the next 2 points, connected those 2 points with the secant line, and found that slope to approximate t prime of 3. Right? 3 just happens to be the number between 1 and 5. So that's why that secant line would give me an approximation for t prime of 3. And that slope is -5.75. So let's see. From t prime of 0.5 to t prime of 3, the derivative has gone from, the slope has gone from -7 to -5.75. That's an increase in value. So if t prime increases over an interval, that means t double prime was positive over that interval. All right, so this doesn't really help us disprove anything, okay? If anything, it is consistent with the assertion that t double prime is positive. But of course, we've only checked a part of the interval. So then I went on and I grouped the next 2 points. All right, and by the way, this is a calculator problem, so this goes a lot quicker than how I'm explaining it. I'm trying to explain it slowly. So the next 2 points, when x equals 5 and x equals 6, this will approximate t prime of 5.5. T prime of 5.5 ends up being -8. So if we see what happens from x equals 3 to x equals 5.5, our approximations for t prime went from -5.75 to -8. That's a decrease. So we can see that t prime has decreased from x equals 3 to x equals 5.5, which implies then that t double prime must be negative at some point between 0 and 8, more specifically at some point between 3 and 5.5. However, the question asks for between 0 and 8, and so that's why I stated 0 and 8. Okay, and we can also, we do also have to assert that t prime is continuous and differentiable. So t double prime being negative on this interval, in order for us to make that claim, it must be the case that t prime is continuous and differentiable. And how do we know that t prime is continuous and differentiable? That goes back to the statement here that t is twice differentiable. All right. And there you have it. So your final answer would be some statement that resembles this, but the work being shown, if you look up the scoring guideline, if you Google this problem, I'm sure some of you have, the scoring guideline states that you have to have some kind of like slope argument. And so, you know, you would have to have the work up here shown somewhere. This work, in addition to this statement, would give you full credit on this problem. All right, ladies and gentlemen, that's all for today. Hopefully this helps. If you have any further questions, do not hesitate to ask me. But until then, take care. Bye.